In this video, I want to talk about circle theorems, all these 8 different circle theorems you need to know for your GCSEs. But before I do, I want to say what these circle theorems are about. They're basically about finding out missing angles. So, for example, in this circle theorem, it's saying, if you know this angle, then you know this angle because they're equal. That's the quick introduction to what circle theorems are about. Let's quickly start describing each of them. How do they work? So this one, first of all, you have to describe the situation. So you've got two angles, both on the edge of the circle or the circumference of the circle. And they both start from the same places. So this angle starts from here and ends there. It goes up and then back down. And so does this one. It starts from the same point, up and then back down, right? So if you've got two angles, both on the circumference, and they're what we call in circle theorem talk subtended. Yeah, you'll see that word in my next video when I go through the proper descriptions of these circle theorems, subtended. Anyway, it just means it starts and ends, from the same point. Yeah, so they're subtended by the same point, then those angles are equal. So I can make another angle over here, anywhere on the circumference, as long as it starts there, ends there, it's going to be equal. They're all going to be equal like that. Okay, this one's quite similar to that one. Basically, what it's saying is that this time you've got an angle on the circumference and the middle. But the thing that's similar to that one is that they're subtended by the same point. So this angle and this angle start from here and end there, like this. Start, end. Start, end. When I say start, end, I could start from there and end there. That's not really start, end, but you know what I mean. So anyway, this one is saying that this angle at the center is twice the angle at the circumference. The next one is saying if you make a triangle in a circle, and one side is a diameter, and all corners are touching the edges of the circles or the circumference, then you get a right angle triangle. Yeah, and obviously the right angle is going to be opposite the diameter bit. This one is saying if you have a four-sided shape, a quadrilateral, all the corners again touching the edge of the circle, then the opposite corners add to 180. This is just a complicated way of saying it, isn't it? Or a mathematical way of saying it. That, these two add to 180. So do these two add to 180? Doesn't matter what four-sided shape you make. This is just some random four-sided shape I made. And this one, well, it uses a thing called a tangent. So a tangent is a straight line that touches a curved surface. Right, so here's a tangent, there's your straight line, and here's a radius coming from the middle to the straight line. The angle between a radius and a tangent will always be 90 degrees when they meet. So if I made another tangent there and the radius met it, there will be 90 degrees between it. Just to be clear, this 90 degrees is not between the radius and the edge of the circle. This line goes all the way up to this line here, just to be sure that this angle is between the radius and the tangent. I'm just making sure because, it's very hard to make that clear on the drawing. Anyway, the next one is... you got two tangents, one here, one there. This is a bit odd drawing of a tangent because tangents usually go, both ways. It touches and carries on, touches a curved surface like this circle and carries on that way. But there's a reason why I've drawn it like this, that it starts from the point it touches and carries on this way, and so does this, because I want to show that this length is equal to this length. So basically what's happening is you got two tangents, and they meet each other, and what it's saying is the distance between where the tangents touch the circle to where they meet each other are equal. So this distance is equal to that distance. Any two tangents, you do that to one circle, two tangents to one circle, with the distance where they meet each other, the point to where they meet each other to the point where they meet the circle is equal. Yeah, but I did say in the beginning, circle theorems are all about angles. So although this when you're describing this circle theorem, you say the lengths are equal. The way it's actually used is that you make a line between the points where the tangents meet the circle, like this line here, this dotted line here, and automatically you get an isosceles triangle. And if you've got an isosceles triangle, you can say these angles are equal. This next one uses tangents again. Okay, here's your tangent, and there's a triangle with all the corners touching the circumference of the circle. And it's a bit of a weird description. The way it works is a bit weird. Basically, the angle between the tangent and the triangle is equal to the angle on the opposite side, right? That's the quickest way I can say it. So this angle touches this side. Opposite to that side is this angle, and they're equal. This double line just means the angles are equal, just like I drew on that side. This angle is equal to that angle, and that angle is equal to that angle. Just to kind of explain a bit more, say you had an angle on this side instead. You still got an angle between the tangent and the triangle, so an angle there. That's equal to the angle on the opposite side. So this angle is touching this side, opposite is this one. So this angle and the triangle would be equal to that angle there. So that's the description of that rule. And then finally, we're on this rule here. What this rule is saying is that if you've got a chord, so hopefully you know what a chord is. If you don't, a chord is just a straight line that goes from one part of the circumference to the other, just a straight line. And if you have a line from the center that meets the chord at 90 degrees, automatically is going to cut that line in half. So this length from here, where the line from the center meets the chord, that point there, from there to there is equal to from there to there. Basically cuts the chord in half. Or you could say it the other way around. If you cut the chord in half with your line from the center, then it would automatically be at 90 degrees. There would be 90 degrees to each other. This line from the center and the chord.